all the trig functions that we've learned about, they have inverses. And it's important that you understand moving forward. I'm going to sound like a broken record every time I say this, but if you take a trig function, the goal is that its inverse is also a function, and that's going to require us to restrict the domain. That's the main idea of the day. So as we move through here, I just want to say that the inverse of a trig function is the result of switching x and y. That's how we've always tackled the concept of inverses, even since Algebra 2. Switch your x and your y, your input and your output. As a result, the output value, in other words, your answer to an inverse trig function problem is going to be an angle measure. It's going to be like on your unit circle here. Your answer to inverse trig problems are going to be these radian measures here. Get that out of the way. Okay. So notation is we can represent inverse trig function with two different ways. You can represent it as this little like sign to the negative 1 power of x. The way that you say that out loud is arc sine of x. Either one of these is acceptable. Yes. It's always going to be radians in this class, and that brings me to this thought. Make sure on AP test day, your Inspire is in radian mode. I've asked Mr. Copeland to kind of make sure of that, and if I need to handle each and every calculator that day, I can. But yes, everything in this class is always in terms of radians. So you're going to say arc sine if you read it out loud, which is, if you kind of admittedly is easier than saying something about the arc sine to the negative 1 power. We'll say arc sine. It's inverse sine. So if you wrote this statement right here, sine of pi over 6 is 1/2. I'm looking at the unit circle. Sine of pi over 6 is certainly 1/2. If I needed to flip that around and write it using arc sine notation, I would write it as either of these. I could write arc sine that way, but the output is going to be that pi over 6. So the input, how I would write it is arc sine of 1/2 is pi over 6. Or you could actually write out ARK, arc sine. And I think that should have an E on it, arc sine of 1/2 equals pi over 6. Either of those is acceptable. When you say it out loud, say arc sine, and it sounds smart. Okay. Here is this a sine function or a cosine function here in front of us? It's sine. How do you know that? It starts at the midline. Okay, it looks kind of like an S, and it says, because trig functions are periodic, we have to restrict their domain to create corresponding inverse, the key word there being function. So when I first looked at this, I was kind of like, okay, how am I going to explain why the domain has to be restricted? Circle that word function. If I took this sine function, here's what its inverse would look like if I reflected everything over the line y equals x. Have to be careful about how I draw this here. Okay. That's what it would look like. Sketch that on your paper. Is what you're drawing right there, this graph, is it a function? Why not? The vertical line test, we have repeating x values. It's an old school like thing that you should just have in the back of your brain, that this is not a function because it fails the vertical line test. So what we're going to do is we're going to restrict the domain, and in your picture there you can see this bolded portion. The input values we're going to restrict to over here are going to be negative pi over 2 to positive pi over 2. That means that we're going to restrict from here to here. And if you're just working in pencil, just kind of bold that up. That's pi over 2 as an output, and negative pi over 2 down here. So because the inputs are going to be restricted on the original sine function, then we're going to restrict the domain of the inverse so that we can call it a function. Now, this red part, that is a function. It passes the vertical line test. There are no repeating x values. This is just to explain to you why the heck the domain is restricted. And down here you can see that right underneath there, typed out, we're going to restrict the function of y equals sine of x to this domain, negative pi over 2 to pi over 2. Why are the hard brackets? They are included. That's really the depth of what you need to know there. Hard brackets, remember, include the values. That's sine. Now, let's look here. We've got a cosine function. And if you were to draw its inverse, it would look like, again, I've got to just kind of be careful how I draw this. It's kind of tricky. That, I mean, of course you could keep going because it's periodic. But because of the way this is shaped and it's not to scale, I apologize. It's kind of lopsided. But this is not a function, the same thing I said before, so we have to restrict the domain. And over here in the picture, you can see that it's slightly more bold. We're going to restrict the domain. The input values over here are going to be restricted to 0 to pi. That means the y values over here, the range, is going to be restricted from 0 to pi. Just the red part. Because the red part we can call a function. Now we can call it truly an inverse function. We couldn't call it a function before because it failed the vertical line test. So it says underneath that, for a cosine of x, we're going to restrict our domain to 0 to pi, hard brackets on, including those values. Lastly, without a picture in front of us, for the tangent function, we're going to restrict the domain from negative pi over 2 to pi over 2. The brackets there are soft because of the vertical asymptotes. You have vertical asymptotes at these locations, so you can't say that those are included values. So if you want to make a note, soft brackets because of the vertical asymptotes. Now we're going to actually do the work. Turn your page over. These shaded regions come in handy. It says it's important to remember to consider domain restrictions when working with inverse trig functions and values. So this lays it all out for you. Here is the arc sine function, and it's restricted. If you think about it in terms of a unit circle, on the first page we said, and we reasoned our way through, okay, we get it. We're going to restrict it from negative pi over 2 to pi over 2. Well, in the unit circle, that's going to be quadrants 1 and 4. Because negative pi over 2, I hope you're paying really close attention because we haven't said this in a while, negative radians just mean that you're swinging downwards from that x-axis. So we're going to consider all of these in quadrant 4 to be negative radians. In quadrant 4, negative radians. That's going to make example 2, part B, a little bit tricky, but I think that by the time we get there, you might feel okay about it. This tells you that, all right, we're restricting the domain value on the original cosine function to be 0 to pi, so the arc cosine function has a restricted range. Because when we talk about a function and its inverse, the domain, their ranges are just switched. X's and Y's are just switched. Well, 0 to pi is everything in quadrants 1 and 2. And then for tangent, we restricted the domain from negative pi over 2 to positive pi over 2. And just like over there in this arc sine function, that's going to restrict our domain to quadrants 1, or range, excuse me, to quadrants 1 and 4. So negative radians again. Here's how you read these. Actually doing the problems is pretty darn easy. So watch how this works. Evaluate the following expression, arc sine of negative root 2 over 2. Now, it certainly helps if you have a unit circle handy, but hopefully by now you can maybe start to have memorized the ordered pairs all the way around. But I'm just going to put my unit circle up here to help us out. Where is, listen to how I say this to myself, where is cosine negative root 2 over 2 on the unit circle? Cosine, negative root 2 over 2. Oh, there's one right there at 3/4 pi. And if I keep going, negative root 2 over 2. Oh, here's one right here as well in quadrant 4 at 5/4 pi. But even though there's two locations where cosine is negative root 2 over 2, I'm talking about arc cosine. So out of the two that I just found in my unit circle, one of the answers was in quadrant 2 and the other one was in quadrant 3. What's the only answer I can put for arc cosine because we're restricted? You can only put the quadrant 2 answer. And remember, our answers are the radians, so my answer is 3/4 pi. Don't worry, we're going to do that again. So 3/4 pi. And I just want you to make a note to yourself. Cosine is negative root 2 over 2 in quadrants 2 and 3, but we are restricted to quadrant 2 as being our only answer for the arc case because of that shaded region right there. So again, I found where cosine was this value and then narrowed it down based on the restricted range. No, you really need to either memorize the unit circle, just straight up memorize it, or you need to reason your way through how to derive the values on the unit circle, which takes a much longer time. I know that I recommend the second I give you the test, if you're a person that needs to just sketch out the unit circle really fast and label everything, it takes time, but if you're a person like me, I constantly pull this and reference it. So you may want to draw this on your test, okay? I want to skip B and go to C. We'll come back to it. It says arctan of root 3. So I have to figure out where tangent is root 3, and that's going to probably show up a couple of times on my unit circle, but then I'm going to be restricted to either quadrant 1 or quadrant 4 in my answer. So if I'm getting my unit circle here, tangent is y over x, sine over cosine. So where is tangent going to end up being root 3? Is it going to be where I have 1/2 divided by root 3 over 2? Is it going to be where I have root 3 over 2 divided by 1/2? And if you're not sure, take a second and show some work right here. I want you to do that. I want you to figure out which of those options reduces to root 3. 1/2 divided by root 3 over 2, or root 3 over 2 divided by 1. These are ways for me to write something you're not engaging with the math. I want you to try it and see. And if you think you know it, then write it down and prove it to yourself. Okay? It's where you do root 3 over 2 divided by 1/2, and that happens at pi over 3. Where else would I end up with a positive root 3 for tangent? Here I would end up with a negative because it would be a positive over a negative. Here I would end up with a what? A positive, because it would be negative and a negative. So it also happens that tangent of 4/3 pi would also give us √3. But that's in quadrant 3. And arctan has a limited output of just quadrants 1 and 4. So out of those two answers, what is the only viable answer for an arctan problem? The pi/3, the one that shows up in quadrant 1. Pi/3 is our answer. Now let's go back to B, because it has an added thing to figure out. Arcsine of negative √3/2 means I'm going to think about where sine is negative √3/2. And that means the y value is negative √3/2. And that's down here. It occurs at 4/3 pi and 5/3 pi. So you might be thinking, oh, I get it. It's going to be the 5/3 pi. But that's incorrect. Because if you write 5/3 pi, what you mean is you've gone around the circle 5/3 pi radians, and you have now gone into the unshaded region, and that kind of just violates that whole thing. So instead of writing positive 5/3 pi, yeah, let's swing down in the other direction. That's why you wrote this. These are all going to be negative radians. What's coterminal, in other words, what would be the same exact landing point would be negative 1/3 pi. That's the same as positive 5/3 pi, negative 1/3 pi, or negative pi/3. Now, if we want to just write a little bit extra there, then you might want to write negative pi/3 is the same terminal ray as 5/3 pi, but it must be negative because of restricted range, or you can write restricted domain or whatever you need to put. And I did write that on my Schoology notes. I wrote it a little bit differently, but that note isn't on there. So if you're looking back and you're like, I got the other two, but this one's just so weird, it's because you can't swing around into the unshaded regions. You're just not allowed to do that. So instead, you can go up this way and stop, but to get into quadrant 4, you're going to have to swing down. You're going to have negative radians. And the same thing applies on the tangent arctan. You have plenty of these to practice, so you can kind of get the gist. Now you will see one of these on your test. I promise, because I wrote the test, right? So you're going to see one of these on your test, and it's got ordered pair labeled right here at point P. And the way they label point P is positive x, positive y. So before we start, I want you to work your way around the circle, and I want you to label points Q, R, and S. What would you label point Q in relationship to point P? Negative x, y. What would point R be? And what would point S be? Easy peasy. Let's read. The angle theta is in standard position. You can see that in the picture. The terminal ray intersects a unit circle at point P, whose coordinates are x, y. That's all in the picture. Points Q, R, and S are the result of the terminal ray being reflected over the y-axis, the origin, the x-axis, respectively. For each of the following expressions, determine which label point intersects the terminal ray. So our answers are going to be either point P, point Q, point R, point S. Let's tackle these the same exact way we did example 2 up there. Where is cosine x in our picture? Where is cosine theta x? point what and point what? And you should really have grasped by now an ordered pair is just cosine theta comma sine theta, period. So at point P, cosine is x, and at point S, cosine is x, but I'm restricted, look at the top of your page, at arc cosine, because the problem is arc cosine of x. Is it going to have to be point P or point S? Point P, because arc cosine is limited to quadrants 1 and 2. Your test will be a multiple choice question where it'll have like points P, Q, R, or S, and you pick the right one. So part B, where is sine negative y? R and S. You should really be able to pick those out quickly. But arc sine is limited to quadrants 1 and 4. So it's got to be point S. Moving right along, where is cosine negative x? Q and R, right here, negative x. Cosine is the first part of the ordered pair, but arc cosine is limited to quadrants 1 and 2, so we have to go with point Q. Let's think about this last one. Where would tangent end up being negative y over x? Q and S would give me a negative, because a negative divided by a positive or a positive divided by a negative. But arc tangent is limited to quadrants 1 and 4, so it's going to have to be point S. Here's the tricky part. Let me make sure that one of these is on your homework, because if it's not, I'm going to explain it right now. Perfect. Okay, on your homework, go to the back, let's just do number 11. This is the tricky one. Again, you're going to have a test question like this, so I want to make sure I explain it really thoroughly. Same exact style of problem. We're going to tackle it the same exact way, but look what they did. They labeled point S this time. It does not matter how they label a point. They labeled point S x comma y, and that's not a typo. So how would I label point P in relation to that? No? The x value is still going to be the same. It's the y value that's going to be flipped when you reflect over the x-axis. Think about it this way. I'm going from way underneath to way over. And so we're talking about a vertical difference. So the vertical value is what changes. That shouldn't be challenging for you. How would I label point Q in relationship to that? The diagonals are always easy for me. Yeah, you just switch it all. Diagonals are always completely opposite. And then here I'm just changing my horizontal, so it's the x value that's going to be opposite. So whatever point they give you, you have to have the skill of reflecting that. If you mess up on the labeling, then everything else falls apart, unfortunately. So now let's work through this. Where is sine, based on the way we labeled our points, where is sine negative y? Q and P. And which of those has to be our answer? P, because arc sine is limited to quadrants 1 and 4. Where is cosine negative x? Q and R. So it's got to be point Q. Where is tangent going to end up being positive? Q and S. So the answer has to be S. So the more you do these, the faster you're going to get. The more you do these, you're going to just kind of naturally memorize these shaded regions. Sine, arc sine, and arc tan have the same shaded region. Is any inverse trig function the answer going to end up being something in quadrant 3? No. Okay. So just kind of observe those things. That's where I'm going to leave you to practice. If you're a person who has relied, and you have to be honest with yourself, if you've relied a little heavily on the answer keys, then you're the person that definitely needs to go back through and work the problems again. If you truly are working the problems, you're checking your work on the answer key after that, and everything is looking good, then you're right where you need to be. If only you really know how much of a crutch you're using those answer keys as.